Hey guys, sorry, I'm just kinda woken up. Try and give me like a few minutes while I just set up. Oh, what the hell, man? Damn it. Okay, now we're good. We're good. Let me just grab the file and then we should be good to go. What are we doing? We're doing differentiation. Okay, cool. We are doing differentiation. All right, so differentiation 2016 paper. Yep, sweet as. Let's just get that paper. It's gonna be a bit messy, but we'll try and figure it out. Is there an echo happening? Okay, that's all right. Let's just download that paper. Sorry guys, give me 1 second. Trying a new setup. Just trying to get this. Here we go. Add page. Insert. Print out. Downloads. There we go. Now I think today is differentiation, man. Yeah, it's first day back at school, guys, and I have to say, like, yeah, it was it's different, right? Seeing all the kids for the first time in 3 months. Yeah. All right. So we're going to be working through the 2016 paper. What we're going to do is, if you guys want to have a look at that paper and just let me mute this so I don't hear myself. Just give me a yell out if anything freezes, sir, guys, because like, this is a new tablet, but and I'm kind of doing it from a different setup because, yeah, my wife's still working at the moment, so that's all good. So what we're gonna do is the usual, like, I'm not gonna be recording this or anything because, yeah, it's just how do I call it? It's just weird today, so it's fine. If you guys want me to work through any particular questions, so I'm happy to give you guys some time to have a look at the questions, and then you guys can actually decide if there's any particular question you want me to go through. So I will actually chuck up the paper link on the chat, and then you guys could quickly have a look at that paper. All right. Otherwise, I'm happy to go through, like, from this beginning, from like achieve merit and excellence. Yeah. We got time today. We got time because it's like I'm not in a rush. So got lots of water, so we can just keep going when you guys are ready. Can't even see the names today. Jeez, man. Oh, Ignore, you've actually decided to join. Nice to see you, Ignore. Alright, Crystal's actually picked a merit question first. I guess we'll get started with that merit question, which is 1C. Because that should be a merit question. Yep. We'll do merit and excellence today in differentiation. Because, I mean, I reckon, like, I think it's good to do the merit and excellence questions, particularly for differentiation paper, because even if you get the question wrong, you can still get the achieved grade, and all the skills you're going to need for achieved, you're going to get from the merit questions anyway. So we might as well just start with merits and just kind of keep working through those questions. So as I said to you guys before, right, like, remember this, right? And I know I'm going to talk here, but if you guys want to start on this question, you can start on this question. So remember that when you guys actually go into a question, you've got question 1, question 2, and question 3, right? So generally speaking, you're going to get achieved, merit, excellence. So there's like 5 questions. Points wise, you're looking at 2, 3, 5, 6, and then 7 or 8. So if that's the case, right, so how do we want to break this down? If we break this into time, I generally say that for achieved questions, you want to spend about 1 to 2 minutes, not more than that. All right. And then for the merit questions, possibly you want to be spending anywhere between 3 to 5 minutes. But even that's like, you kind of like, you really want to be spending about 3 minutes on it. And excellence, you want to spend about 10 minutes on that question, on an excellence question. That's basically the timing that you guys got to do. All right. So this merit question, I'm going to say that you guys should be able to kind of like get through this in about 3 to 5 minutes. And if you're taking longer than that, then I would suggest that you move on to the next merit question so you can still get that 5 points. All right. So it's all about strategy, guys, for differentiation. And let's say you stuff up the merit question. Guess what? You're going to get, so let's say you stuff up a merit question with here, instead of getting a 5, you might actually get a 2 for it. Plus, if you do another one more question earlier, then you might actually end up getting like 3 points for it. So it's really important that you guys actually just kind of like get used to the idea of merit questions with differentiation. Yeah, let's just get rid of that. Oh no, not that. You, oh jeez, man. Talk about. Cool. So I'm gonna give you guys let's see, I need the schedule up here just so that I keep track of our grades so that we're not wasting time. Cool. Yep, we'll go through that, Astrid, so it's all good. Let me know if you guys want me to go through the answer. Otherwise, I'll give you guys some more time to work on it. Yep, sure, Cheetal. So what we've got is we've got parametric equations. Now, you guys are going to get the formula sheet. So with the formula sheet, you're going to get the parametric equation thing in there. Let me just, what is happening here? Give me 1 second, guys. I'm just going to get that formula sheet so you guys can actually see it. Oh, that's interesting. Oh, come on, man. This is just silly. I was trying to add something and then now it's completely disappeared. And there we go. Add a source. We want to have screen capture. Should be back now. Sorry guys, it's just been a bit of a fun day today. I guess it's the level 3's turns to kind of have this bit of tablet suffering. Anyway, Fiona, I'll talk to you very quickly about the graphics calculator, but it's just these guys have been waiting for this answer. So as I said, the first thing you want to be doing here is you want to differentiate x first. So you've got x is equal to 2 cos 2t. So what we're going to do is we're going to actually figure out what dx dt is. So when we actually do dx dt, we are going to get, what do we got? 2 cos 2t. So cos differentiates to negative sine of 2t. And of course, we have to multiply by the differentiation of whatever's inside the bracket. When you differentiate 2t, you're going to end up with 2. So we've got dx dt is equal to negative 4 sine 2t. So that's the first part. Now, if you guys actually have got this part already, negative 4 sine 2t, you can actually get an achieved for this straight away. All right, so just this part here is actually going to get you an achieved. But what we are looking for in the question is we're actually looking for dy dx for when t is equal to pi over 4. So we need dy dt, because parametric equation, guys, remember this. Dy dx is the same thing as saying dy dt multiplied by dt dx. So if you guys see like x equals to t and y equals to t in the question, you know straight away that you're going to be doing parametric equation and you're going to be doing differentiation of parametric equation. So with y, we've got y is equal to tan squared t. Now this is really important, all right? A lot of people actually see that just Joseph, try changing your resolution on your quality, man, and I think it should be okay. So yeah, try that. Yeah. So remember that, like, the mistake I've seen people do with tan squared t, I don't know why, but like people tend to do this, and you've got to be really careful with this, all right? Some people go tan t to the power of 1, and they just start doing like kind of like really silly things. What's really good to do with this is put a bracket around tan t like this and squared, because when you do this, then what happens is you guys can actually do chain rule for this. So when you do chain rule, what's going to happen is you're going to get 2 times tan t to the power of 1 multiplied by the differentiation of the bracket, which is tan t. So if we differentiate it, we are going to get sec squared t. Yeah, parametric is an easy merit, and it's like I remember when I used to work with some of my students who were like, "Oh, man, sir, I just get so nervous about differentiation." I'm like, "Look, just learn parametric equation. You're going to get five points for that." Because if you nail that merit question, it is becoming 5 points. Okay, cool. So we've got that. So either one of those is going to get you achieved. We're going to do dy dx now, which means we're going to write dy dt multiplied by dt dx. So dy dt is actually 2 tan t multiplied by sec squared t divided by dt dx. So we've got to flip that, which is negative 4 sine 2t. Now the problem is in your graphics, in your calculator, you can't actually do sec squared t. I can never get that right. We're going to write this as 2 tan t multiplied, no, not multiplied. Sec is 1 over cos, so this is going to be 4 sine 2t cos squared t. All right, so all we got to do at this point is just substitute t is equal to pi over 4 and actually solve it. Now, I do not want to try this, but I'm nervous about this because my thing's been crashing the whole time, but I'm going to try it anyway. If it crashes, I do apologize. I'm going to remove this. Let's add a new source. Screen capture, monitor capture, desktop 1. There we go. No, that's too little. All right, let's see if this is going to work. Trying to do my old setup here at the moment. All right, so here we go. We got the calculator. That's beautiful. So one quick way of doing this, especially with pi over 4, is what you could do is just put down pi over 4 as your answer, so it gets stored as your answer. So I do something like this. I go shift pi divided by 4 and I'm going to leave that as my answer. Why? Because now, instead of typing pi over 4 every single time where there's a t, I'm just going to write this as 2 multiplied by tan of answer. And then I'm going to go divided by negative 4 sine 2 times answer, and then multiplied by cos squared t. Now this part is really important. What you want to do is you want to put cos of t, or in this case I'm going to put cos of answer, and I'm going to make sure I put that squared outside. Close everything. Boom, I got negative 1 right there. So we when you get this as negative 1, you end up getting a merit grade, I believe. Yep. To get rid of sec squared t, remember that this is actually 1 over cos squared t. So in your formula sheet, you will be given this as well. So you can actually try and kind of like, if you forget it, just go into the formula sheet to try and get those little tips. Any questions with this, guys, before we kind of like move on to the next merit question? Let me know. Yeah, I'm like streaming from like a rocking chair, man. It's not the best place to stream, but when it's desperate times. Cool. We go to the next question then. Liv, yes, just doing merit and excellence questions because I guess the reason is because it's just if you understand how to do merit questions, generally you're getting practice for the achieved questions anyway. So that's why we're kind of like just focusing mainly on the merit questions. Like if you look at this particular question here, you know, if you differentiate that function, you're probably going to get an achieved for it, I bet, but I'm not sure. Let me just double check. No, slightly a little bit more work, is it? dp dy dx. Cool. Anyway, I will leave this up for you guys, so you guys can actually have a go at this question. And like I said before, if you don't know what to do in this paper, unlike level 2, when you're going to have like a mixture of integration and differentiation, this is differentiation paper. If you don't know what to do in the question, find the formula, differentiate it, you're most likely going to get an achieved for it. All right. So, and that's also a good way to start a question as well in differentiation, because you know you got to differentiate it. Yeah. I was gonna say, Fiona. Where are you based, Fiona? Let's see if we can try and figure out a way to try and get somebody to help you out. Christchurch, damn. Do I know some people there? Couple of options, Fiona. It's like could have a chat with them, like just drop me what do I call it? And then like if you're on Instagram, just check on Instagram and see if maybe I can have a chat with some people that I know that they can possibly help you out with it. Yeah, that's what I was gonna say, Fiona. Your school could have it, and I didn't want to ask your school because I know a few schools around Christchurch, and like I was just gonna basically just give them a call and say, look, can you help her out or something like that? Because like even if you go and have a chat with your maths teacher and say, look, here, take my phone for, can I just borrow the calculator? Take your, I'll bring the calculator back. You just hold on to my phone. That's another way you could do as well. Yeah. Sorry, Liam, I'm just kind of going through that question there. Like, sec squared x, you can't actually put in the calculator, Liam. So that's why we go 1 over cos for it. That's the whole reason behind it. Because if you think about it, in the calculator, we've got sine, cos, and tan, but we don't actually have cosec, cot, and sec. It's all right, man. It's all good. All right, guys. I'm actually going to power through this question at the moment. I hope you guys have had a bit of a good crack at it. So what we've got is, here's my pen. So like I said to you guys before, we're going to have a look at this question. So we've got two tangents to the curve at P and Q are perpendicular. Okay, that's fine, whatever. Q is the point at 6, 4. That's pretty useful. There we go, that's our point. Now, what it's actually saying, what is the coordinate of point P? X coordinate. So they just want to know what is that coordinate right there. So what we're going to do is, the first thing is first, we're going to differentiate and find the gradient function of this equation. So we've got y is equal to quarter. Just going to get rid of this sucker, hang on. So we've got quarter x minus 2 squared. So when we differentiate this, we're going to get dy dx is equal to, we've got to use chain rule for this, so we're going to get quarter multiplied by 2 x minus 2 to the power of 1. And of course, I know I always do this, but like I actually say like multiply by the differentiation of the bracket. Even though it's 1, I know I don't have to write it, but I get into the habit of writing this. And the reason is because with chain rule, most of the time people forget to multiply the differentiation of inside the bracket, and that's where they lose the points out on. So really, really important that you just kind of get into the practice of differentiating. Even if it's 1, you're like, oh, just gonna get that practice going. Of course, like after you've done it for like 20 years like me, you're like, oh yeah, don't really write that one. But for you guys, it's like a nice little reminder. Okay, so what do we have here? We've got dy dx is equal to half x minus 2. All right, so that's what we have. We can actually kind of blow this up, expand this, not blow this up. Half times negative 2 is negative 1. So this is my gradient function. Now, what I can do is I could actually find out what is the gradient when x equals to 6. So basically, I want to find out this yellow line here and what's the slope of it. To find the slope, I just need to put x is equal to 6, because if I put f dash of x, so f dash of x and dy dx is the same thing, so it's just half x minus 1. So if I actually put f dash of 6, it's actually going to give me the yellow line there, which is, I've got, geez, this is sucking today, half times 6 minus 1, so that's going to give me 3 minus 1, which is equal to 2. So this yellow line has actually got a gradient of 2. Okay, hopefully that made sense there what I've done. So all I've done there is I've just figured out what the gradient of that yellow line is, which is 2. At p dy dx is negative. Wow, okay, wow, that's pretty serious. So now if you guys think about it, we actually have this yellow, let's go green. We've got the green line there, which is actually perpendicular to the yellow line, which means the green gradient multiplied by the yellow gradient. So I'm just going to write that down here. M1 times M2 equals minus 1. So this is like thinking about it like this. So if I take the green gradient and I multiply it with the yellow gradient, I'm going to get negative 1. So that's what that rule is with, what do you call it? Sorry, just getting distracted here. With perpendicular gradients. So to figure out what that green gradient is, we've got to actually write this as m1 is equal to negative 1 divided by m2. Now m2 is actually 2, because that's what we find out, so it's going to be negative half. So basically what that's telling us is the green gradient is actually equal to negative half. So Joseph, when you actually multiply two perpendicular gradients, you have to get negative 1. Now sometimes you might actually see it like this. Wrong pen. You might actually like see like normal, gradient of normal is like -1/m. You might have seen that. All I've done there is just like I kind of like when I multiply the two gradients. So if I cross multiply this, I'm going to get m times normal is equal to -1. So that's all I've done here with the two gradients. Yes, Kian, when you take a for two lines to be perpendicular, the two gradients have to multiply to -1. That's when it's perpendicular and it's like kind of like cutting it off at 90 degrees. Well, normal, I guess they kind of say it like this, right? So if I was to draw a gradient like this, then what they say is like the normal is going to be at perpendicular. That's what it means. And so in 3/2, actually 3/2 might work. Just trying to see, do I need a grid? Okay, let's just do a quick little grid here. Okay, so imagine it like this, right? So if I have a gradient that's going 2 across and 4 up, so that's what this gradient is going to look like. So if it's 2 across, 4 up, so that's 4 divided by 2, so the gradient is actually 2. But if I actually flip it at, so because that's at 2, now I've got to go like 4 across and 2 up, which means I'm going to get like another extra grid there. Sorry, it's just my terrible drawing at the moment. But so that's going to be 4 across and 2 up. And really what I'm trying to kind of do is like, what is the gradient this way is going to be? It's going to look, I think I've drawn it in a very ugly looking shape here, because the answer is, that I'm supposed to get is like -1/2, but it's just a very, if I had done it in a very nice grid, it would have actually come out as a perfect cross, but my grid is like not even, so that's why it's looking that ugly. But generally what happens is it's like -1/2 is the green gradient there. But if I'd done it in a beautiful proper grid, it would have kind of like been like a perfect X. So hopefully that made sense, guys. Sorry, I kind of just got sidetracked there, but just a little bit of revision from level 2. All right, so what we have discovered is we've actually figured out that the gradient at P is actually equal to -1/2. Because that's at the point P is when you have the green gradient, and we've actually just figured out that the green gradient is equal to -1/2. So that's what we've actually done here. Now we also know the gradient function, which is actually 1/2 x minus 1, which equals to -1/2. So it's just a matter of rearranging now. So we've got 1/2 x equals 1 plus 1/2. No, 1 minus 1/2, sorry. And we're going to get 1/2 x is equal to 1/2, which means x is equal to 1, or in this case we're going to actually say, therefore we're going to say P's x coordinate is equal to 1. So grades wise we're looking at merit for this here, and you actually have to get up to this part here for achieved. So you have to differentiate, and then you have to actually try and figure out what the gradient is at P. No worries, Vikesh, it's all good, man. Yeah, so any questions with this, guys? Feel free to just chuck up on the chat. We'll kind of like have it, happy to go through it again, or if anything that doesn't make sense. And if you guys are good with that, we can actually move the next to the other one. Why did we equate the gradient function to the gradient of the normal? Okay, Ayush. So remember, the gradient function actually tells you what is the gradient at like different points of the curve. So let's say I've got a point here called like R. So if I take f dash of R, so if I put the x coordinate of r in the gradient function, it is actually going to give me the slope of the pink line. If I put f dash of p, whatever that x value for the p is, it's going to give me the green slope. And likewise, if I put down f dash of 6, that's actually going to give me the yellow slope. So the x point of p is when the gradient of tangent and normal are equal. No. What we're doing is we're using the tangent. Imagine the tangent is the yellow line, right? So tangent at 6. That yellow line has a gradient of 2. Now the question actually says right here, it is perpendicular. Because it's perpendicular, what we can then do is go -1 divided by the yellow gradient, which is what I did in this step right here. -1 divided by the yellow gradient is going to give me the green gradient. Once I get the green gradient, I can put it back in the gradient function. So the gradient function is right here in the red box. That's the gradient function at any x value along that curve. So is the gradient function the same for all tangents? Of course, yeah, that's what a gradient function is. So the gradient function tells you what is the gradient at any x value. So for example, like that's what I meant by in this whole thing here is in the, I should have done a different color. Let's try the light blue box. There we go. So anytime I put the gradient function and whatever the x values in that gradient function, it is going to give me all the different gradients on any of those points on that parabola. That's what a gradient function does. Ayush, did that answer your question for the gradient function to the normal first? I mean, not normal, like why do we actually need it to... So once we got the gradient of normal, that's when we actually put it back into the gradient function to figure out what the x value is. So say, for example, if I find out that the pink gradient here that I've done, so let's say the pink gradient is, I don't know, like -4 or something like that. If I want to find the value of r, I would need to get the gradient function, which is half x minus 1 equals to -4. And then I'd rearrange it. I go half x is equal to -4 plus 1. I've got -3. Half x is -3. So x is equal to -3 times 2, which is equal to -6. So basically that tells me that the x value there is going to be -6. So that's the whole purpose of using the gradient function to find out what the x value is for any given gradient. All right, guys, let me know if you're ready for me to move on. Cool. One is always good to go. By the way, all of these notes should be available for you guys. So if you just click on the description, you're going to go to the OneNote. And if you go down right to the bottom, I've kind of like, as I said, botch job today, but exam papers, and go right down to exam 2016, and all of these notes should be available for you guys. It should be updating live. So you guys should be able to just kind of like go through and just have a look at it later. All right, here we go. Let's try this one here. I'm not liking the new XSplit software. It is killing this tablet, but cool. So this is an excellence question, guys. And what I'm going to do is I am going to give you guys some time to kind of like have a go at it. So it's not something that I would do like in like 2 minutes or something like that. I'm going to give you guys like a few minutes, and if other people have any questions with anything else, just feel free to ask on the chat. Yeah, so that's what we're going to do. Just a heads up for this question. This is, you know, you've got f double dash of x. So I'm looking at it to get achieved. This is what you need for achieved. Differentiate it once for achieved. I don't know why this oh, I think I know why. Yeah. So differentiate it once for achieved, differentiate it twice for merit. So I'll give you guys, what's the time right now? 38:50. Okay, let's give you guys about 5 minutes at least for this. And have a look at the exponential equation, not exponential differentiation, guys. If you forget how to do it, it's always a good place to start in your formula sheet. What I will do is I'll actually put that formula sheet, formula sheet calculus. So it says yep, that's just from the formula sheet as a little tip for you guys. But yeah, have a crack at this. What's the time right now? 9:46. Yeah, I'll come back and do it at 9:50. What do you do after double differentiating? Right here. Put f double dash of x equals to 0 and solve it, and then you're good. Because it says solve in terms of k, that's the only thing. So guys, what I'm going to do is I'm just going to work out the f dash of x just to kind of like do a little bit here. I'm not going to go beyond that. So f of x is e to the negative x minus k squared. F dash of x is going to be, I'm going to write everything as is, but I have to multiply by the differentiation of this, which is a very ugly looking equation. So, but I've got to use chain rule for that as well. So it's going to be negative 2x minus k to the power of 1, and of course multiplied by the differentiation of this, which is 1. So Joseph, hopefully that kind of helped you get started on that. So then we can say that f dash of x equals negative 2x minus k multiplied by e negative x minus k squared. So that's just for your achieved part. Let me know if you're okay with that, Joseph. Might just do this in a different color. Yeah. And for the next part, Joseph, a little bit of a hint for you. This is the hint. Remember that there's a multiplication symbol between these two things. Yep, product rule, that's the one. Just give me a second, guys. I might just go check if the computer's free, then I can switch over. Alright guys, I'm just gonna go jump onto the main computer, so it might just switch off for a second, but just keep working away and then I'll switch over very quickly. Alright, what do we got? Go live. Go XSplit. Don't know if this is gonna work or not, but only one way to find out. Let's see. Screen capture. Alright, be right back guys, I'm just gonna switch the PCs. I think we're good to go. Are we good to go? Come on, work. Because this is like, yes, this is so cool. I just jumped from like, all right, yeah, let's get to this guy. Sorry. Nice. This is like, I was so worried about that this was going to go haywire, but yes, product rule was what we were supposed to do, Crystal. So I'm kind of going to start working on this a bit more, guys. Hopefully you guys kind of carried on with it. Um, Here we go. So to differentiate this, we've got product rule, which means f dash of x. I'm going to put this as u times v. You can use any other letters if you want, so it's all good. It's not a problem. So we're going to go u is equal to negative 2x minus k, which means u is equal to negative 2x plus 2k. Don't really care about the 2k because when we do u dash, we're going to get negative 2. V is equal to e to the power of negative x minus k to the power of 2. Now we've already done that, right? Because remember, that's what f of x was. So for v dash, all I'm going to do is I'm just going to copy f dash of x, which is negative 2x minus k times e to the power of negative x minus k squared. Hopefully that made sense how I did that. Which means we can actually say that f double dash of x is going to be u dash v plus uv dash. So here is a couple of things that's worth remembering. So u dash is going to be negative 2 times v, so that's going to be e to the power of negative x minus k squared plus u, I've got minus 2x minus k. V dash is minus 2x minus k e to the power of negative x minus k squared. Looks super ugly, but this is what our answer is. Let me just load up 2016 paper schedule. All right, what do we got? Wow, all of this is gone. Jeez, this is so annoying. 4x squared minus 2. Yeah, that's all good. So if you guys actually have got this, then you're pretty much get a merit for this. All right, so where is merit? So this is going to get you a merit. Now, if you go back to the question actually says, right there, the green part there, it actually says, when is f double dash of x equal to 0? And give your answer in k. So we're going to put 0 is equal to all of this thing. But however, we've got a couple of common factors. So we've got this and this. It's a common factor. So that means I'm going to take it out. And I'm going to get e to the power of negative x minus k squared, bracket, negative 2 plus negative 2 times x minus k times negative 2 times x minus k. And hopefully you guys are okay with that. So just to kind of reiterate, this part here ends up here. And of course, the negative 2 is going to be here because we've got those two yellow parts that is a common factor in that equation. So we're going to take it out into outside the bracket, and that's what we're going to get. So our next step is actually saying, because we've got two brackets now. So remember how like back in level 1, when we have two brackets that equal to 0, either one of those brackets have to actually be 0. Actually, yeah, that's a good point. We could take out negative 2 too. That is not a problem. I don't know why I didn't actually take it out. Yeah, because, I mean, yeah, it doesn't matter, but we will take negative 2 out as well, just for you, which means we're going to put this as 1. No, what am I doing? Put this as 1, negative 1. So I'm going to put a negative 2 in the front. I'm only going to take one negative 2, which means that's still going to be negative 1 there. So what we've got here now is either negative 2 e to the power of negative x minus k squared is equal to 0, or what's the other bracket? We've got negative 1 plus negative 1 x minus k minus multiplied by minus 2 x minus k is equal to 0. Now, with the first one, you can't actually get e to the power of, because it's e to the power of something, it's not actually ever going to equal to 0. So this is like, you can almost just ignore it completely and just go to the second bracket. So in the second bracket, what we have is -1 plus 2 x minus k squared is equal to 0. So then 2x minus k squared is equal to 1. We can say x minus k squared is equal to a half. X minus k is equal to the plus or minus square root of half. And it is important that you put that plus or minus there. And then finally, we can say that x is equal to k plus or minus square root of half. Yep. So, you know, and I think that's what you need to do for excellence for this question. So let me know if you guys were okay with that. Any questions on it? How did we go? Did you guys get that? Where was the challenge? So if you think about it, I think this is something that I've actually noticed with exponential excellence questions. They always start off with like like the second part when you differentiate ends up being a product rule with exponential equations. Oh yeah, you're right. I should have actually taken. Yeah, I mean it'll still work out because then that'll become positive and positive. So instead of -2, let's make that +2, right? Just there you go. That should still work out. Yeah, you're right, Angelica. It should be negative. Shouldn't the negative ones be positive? Yes, it should be positive, and it'll still work out the answer. Yeah. Sorry, Joseph, you're right. That Joseph and Angelica, you're both right. It should be +1, but I guess that's why I didn't want to take that -2 because, like, you know, it's just so easy to make these silly mistakes. Like, you know, um, that's why I didn't want to take it out. But you kind of like said, yeah, take out the -2, and I completely forgot that it's actually +1. So if you guys think about it, it's actually not a bad excellence question because it's like it's an exponential equation. You differentiate it, you're going to end up with a product rule, differentiate it again, and then the cool thing is this part. This right here is always going to help you out. All right, because remember that exponential equations can't actually equal to 0, and because they can't actually equal to 0, you can almost like completely ignore one side. So as long as you find that common factor of exponential function, you can actually take it out and then you're pretty much good to go. Oh, this is just not fun. Let me know if you guys to prove that. Raymond, that's a great question, but I can actually show you the where is it? I can show you the answer schedule and you can have a look at this. They don't even bother with that part, man. They just completely ignore that part of e to the negative x squared equals to 0. So they just jump from that line straight to this line here because they just, yeah, it's just assume that that's not going to be possible. Cool. Are we okay with that question? And are we kind of ready to move on to the next merit question? Because I know some people wanted me to do 2C and 2D. I'll check 2D. If it's the limits question, I might just send you guys on might just give you guys a tutorial, which I've done before, which is quite useful. But otherwise, are we ready to move on from this question? While you guys are doing that, let me just add a few things. Man, all of my setup is just disappeared. Yep, cool. Okay, so next question. Achieved. Yeah, so this question here, um, like, I mean, I can go through it, but it's almost like when I try to explain it, it can kind of be like you can get confused in it. So what I'm going to do for you guys is particularly for this question here, differentiation tutorials live, parametric equations, limits. Here we go. This is the one I want. So this is like a 18-minute video, guys, but it pretty much covers, I think, all of these questions. Did I do the 2016 one? I'm sure I did the 2016 one in there. So if you want to learn the limits questions, so this is the 2C one. That's the video that I posted on the chat. Super, super useful. Go check it out. And again, Angelica, to answer your question, um, why does it not equal to 0? If we go back to the equation, right? I want to show you this so it kind of makes sense. Okay, so we've got 2e. So the equation was 2e to the power of negative bracket x minus k squared, right? So it's going to be k squared. So what happens is, what you'll notice is that this, regardless of whatever the k value is, it's never going to actually touch 0. So it can never equal to 0 because there's pretty much an asymptote that's actually here. I could zoom in as much as I want, and yeah, you guys will see that those are like two asymptotes. Well, not two asymptotes, it's like one asymptote, and the curve is just moving. So regardless of whatever the k value is, this red line is never going to go below, where's project? Yeah, so it's never going to go below the x-axis, and it'll never touch y equals to 0. So that's why we know we can just kind of ignore it. If, because think about it like this, right? If we have e of x, then that's what it's going to look like. But then e of x looks like this. So as you can see, like that exponential graph never actually touches the 0. And so that's how we know straight away we can just kind of ignore it and just kind of move on. John T, it's this is the new tablet, but I try to run the my software and it just struggled, man. So I'm now back on the computer and it's been pretty good so far. One of my favorite questions, so which is rate of change. I'm gonna put this out there for you guys, and so let's have a crack at this. What are you guys gonna need? You guys gonna need a large spherical helium balloon. So let me just grab the formula sheet. So if you guys do forget, remember that you can actually go into the formula sheet. This is the main reason they actually have all these formulas. It's because they want you to do rate of change. So with rate of change, what we're doing is sphere, and volume of sphere is 4 pi r cubed. So just to give you a kind of like a hint.
All right, guys, I'm going to give you guys maybe a couple of more minutes for this. Actually, a couple of more minutes, 3 minutes for you guys. And I'll go through this question, all right? And if you do see a rate of change merit question, you should be super happy because that's like one of the easiest 5-pointer you're going to get. And I'll show you some of the tricks for that. Where's my freaking logos? Everything's disappeared. Here you go. Better. And then where's my other one? Add source. All right, Joseph. So if you don't know how to start this, what are you going to get for DRDT? Okay, right. So what I'm going to ask you to do, Joseph, is that try and get into the habit of, especially if you see like rate of change questions, um, write down everything in like D's. Don't write like volume dash or anything like that. So, and then if you have like a rate of something increasing, then you actually write them in terms of dV or dr or dt. That's the first thing that you really want to be doing. Um, I'll be right back, guys. Just gonna grab some water. My throat volume. All right, let me actually go through this question. So, what we saw was, I think the first clue that we have here is we've got a spherical helium balloon, right? So basically, that's why we end up getting the volume of sphere from the formula sheet. So what I meant by this, Joseph, if you're kind of listening in, is this. So the first thing is this. So this is increasing, inflated at a constant rate of 4,800 centimeter cube per second. Now, the part I want you to have a look at is the units. This units right here is going to be your clue. That's centimeter cubed per second. So if you think about it, centimeter cube per second. So it's the rate at which the volume is changing over time. That means we're going to write this as rate dV dt equals to 4,800. So hopefully you guys made that connection with the dV dt. That's the first thing. All right, that's literally the first line right there. I managed to get that first line into this. Now, looking at the second line, it says at what rate is the radius of the balloon increasing? So we want to know the radius of the rate. Rate is the radius of the balloon increasing. So that means I'm going to have to choose a different color here. No, not that one. Let's go with this one. Radius rate that is increasing. So that is dr dt. So is what we're looking at. But it also adds an extra thing. When the volume of the balloon is 288. So this is like when the volume is 28800 pi. So with that in mind, we're looking for dr dt. And this is what's important part that I'm going to say to you guys is when you write the equation. We are looking for dr dt. What we have is dv dt. So if we want to get rid of the dv, because remember, the dv is in the numerator, in the denominator we have dt. So on the left-hand side, we got dt in the denominator, so we don't have to get rid of the dt. We want the dt there. And in the numerator, what we have is dr. That means on the right-hand side, you're going to have dr divided by dv, because that means we're going to have dr in the numerator and the dv in the denominator. And the two yellow parts is going to cancel out each other on the right-hand side to give you whatever it's needed on the left-hand side. Let me know if you guys need me to explain that again. I'm happy to do that, but that is one of the, like, that's how I actually teach rate of change questions, is that always ask you guys to write down what you're looking for, what do you have, and then create the equation. Now, we have this already. We have dv dt, which is right here. We already have that. What we don't have is we actually don't have the dr dv, but how are we going to get it is basically from this equation here. All right, because we know that v is equal to that, and we can actually differentiate dv dr, which means we're going to differentiate that 3 is going to come in the front. We got 3 times 4/3 pi r 3 minus 1. So in other words, we're going to get 4 pi r squared. That's what dv dr is. But we're looking for dr dv, so we're going to flip it, which means dr dv is equal to 1 over 4 pi r squared. Again, I'm happy to pause here and just kind of answer any questions if you guys have any questions. Otherwise, I can just keep carrying on. Okay, I will carry on. So our dr dt is equal to, dv dt is 4,800 multiplied by dr dv, which is 1 over 4 pi r squared. So this is what the formula is for dr dt. But the problem is we don't actually have the radius. So we need the radius when the volume is actually 288,000 pi. So we're going to cut back to this. We need to figure out what the radius is. So we're going to go 288,000 pi is equal to 4/3 pi r cubed. And again, like, I could be sitting here just kind of like rearranging everything, but I'm going to be super lazy. Just go into equation mode, go to solver, and I'm going to type this whole thing out. 288,000, shift pi, shift equals 4/3, so 4 divided by 3, put that in a bracket, multiplied by shift pi multiplied by r cubed, but I could just put x to the power of 3, that's fine. I'm going to do it like this. Now I need to just make sure I click on solve to solve the equation, and you go, beautiful, x is equal to 60 is what I've got, but in my case I can just set that r is equal to 60. So because r is equal to 60, I'm going to come back to my dr dt. I've got 4,800 multiplied, well, not multiplied, I can just go divide by 4 pi 60 squared. All right, I'm going to put this in the calculator now. So go back to normal menu. 4,800 divided by, check in a bracket, we're going to have 4 pi 60 squared. What did I forget? Oh, times. Okay, there we go. So that's going to give me 0.106. And the units is not required, guys. But if you're worried about it, 0.106, I'm going to go back to this. Remember, this is dr dt. Radius is in centimeter. T is in seconds, which means we're going to get centimeters per second here. Joseph, I'm assuming you're talking about what I've done in the red box here. Is that what you're asking me? Yeah, so if you look at the question, right, the question actually says when the volume of the balloon is this volume here. So they're not actually giving us a radius, they're actually giving us the volume. But when we go to the dr dt equation, like in the dr dt equation, we've actually got the radius. So we actually need to find out what is the radius when the volume is equal to 288,000 pi. So that's what we do end up doing here. So we put the volume equation with equal to 288,000 pi, and then we get that radius is equal to 60. Once we get the radius equals to 60, then we substitute that 60 into the wherever it says that r part in the dr dt. Yeah, so let me know if you guys are okay with that, and we can, and then we can move on if you guys want. Oh, geez, 1020. What's our next excellence question? Is it a straightforward one? Oh, it's a good question too, damn it. Actually, I might just call it, man. I'm pretty buggered at the moment. All right, guys. Yeah, well into 10:20. I think I'm gonna call it because I know people have got school tomorrow and I've got school tomorrow. And but yeah, I shall leave you guys with that. All right. Any other other pressing questions? Because I think I'm done for the night, guys, with the questions here. Let me know. No worries, Raymond. It's just kind of do what you can, right? Yeah, guys, I think that's us today. It's getting pretty late. I didn't even realize. Like, shucks, kind of like going off. What do we got? Desktop. Kozak caught and in the calculator. No worries, Sheetal. No worries, Liv. You guys have a good one. Basically, if you want to do Kozak, Joseph, what you got to do is 1 over sine. So you actually got to go like if you want to find Kozak 90, you got to go 1 divided by sine 90. That's how you do cosec. And if you want to do sec, it's actually 1 divided by cos 90. And if you want to do cot, it's 1 divided by tan. Well, if you do cot 90, I'm talking about. So that's pretty much what it is. No worries, Crystal. When are we back, guys? When are we back for our next session? Let me just check. I can't remember. We are back. What is today? Thursday. Oh, wow. I don't actually see you guys till next Thursday. Okay. Yeah, so it's a bit of a while away, but I think after that we're pretty much going 3 nights in a row leading up to the exam. So I'll be here like from Thursday next week till Monday for you guys, the following Monday. Hopefully my voice is still kicking by then. Um, nah, not interested, Kevin, in that. Like, it's how do I say it? It's just something I do because I can do it, man. Fills me, makes, how do I say it? How do I say it? What do I say to my mates? I say to my mates that basically it helps me in my spiritual cup. I'm not spiritual, but like helping people makes me feel good. So why don't, and if I'm making somebody feel good about it, then why not? So nah, I'm all good with that. No worries, guys. You guys have a good one. I'm gonna wrap it up, eh? Don't get me started on talking, or we'll end up like having a chat till like 10, 10:30, 11. Who knows? All right, this little guy can go to sleep finally. Oh, did I hit 22? I didn't even realize. Let me switch over to another desktop, and then we can have a look. See, I want to hit the magic number of 25, man, because that would be so much fun. Well, actually, no, I wanted to hit 100. Like, the reason I want to get 100 is because I wanted to prove one of my mates. Like, I wanted to kind of like say to him, he was like, you'll never reach 100K. And I'm like, true, I did hit 22. Oh, there we go, YouTube Studio. Wow, didn't realize that. That's pretty cool. Oh, well, learn something new every day. No worries, guys. Have a good one, guys. I really gotta go. Okay. Good night, stay safe, and I'll see you guys next week, Thursday.